All right, here are our perfect problem 4 solutions for Math 112. This is supposed to be maybe an ill-advised, but an attempt to bring calculus into Math 112. In Calculus 1, the next class you'll be taking, essentially you'll be spending the whole term figuring out this thing called the derivative. And at some point late in the term, you'll be trying to find the derivative of arcsine of x and arccosine of x and arctangent of x. And you'll be able to use methods that you learn in that class that are relatively easy to figure out that those derivatives are these three things respectively. Unfortunately, these are not the simplified forms of those derivatives. If you Google it, if you look in a textbook, you won't see these listed as the derivatives. You'll see something totally different because these things are simplifiable. So what we're doing in this perfect problem is we're simplifying those things. Because simplifying those things is not a calculus question, it's a trig question. It's a challenging trig question. That's just a trig question. So what I'm going to try to do is figure out another way I can write f prime, g prime, and h prime of x. That's how you say these things. And the way I'm going to do that is by following this little hint here. So the hint tells me to simplify, so maybe I'll do this first. Let's simplify the cosine of the arcsine of x. Well, let's see, what do we know? We know that the sine of the arcsine of x is just equal to x. That's a nice little simplification right there. Unfortunately, we don't know equivalent simplification for the cosine of the arcsine of x. We're going to try to use this one. But how are you going to use that one? It doesn't say sine of arcsine of x, it says cosine of arcsine of x. Well, I can always express cosine in terms of sine. I can express any of my 6 trig functions in terms of sine if I feel like it. And the way I'll do it is by manipulating or taking advantage of this fact. So I guess the things I know that this is true, and I know that sine squared of any angle plus cosine squared of that same angle is equal to 1. And if this is true, it must also be true that cosine squared of an angle is equal to 1 minus sine squared of that angle. Right? Algebraically, subtract sine squared from both sides of the equation. And if this is true, I can take the square root of both sides of the equation to say that cosine of any angle is the square root of 1 minus sine squared of that angle. Technically, there should be a plus or minus in here, but because of the domain restrictions that I'll need for arcsine, I won't need the plus or minus. My point is you can leave it out. So if cosine of x equals this, what I'm being asked here is cosine of something else. That something else is arcsine. But okay, I can take this fact and apply it. I don't know how much room I'll need. To instead of saying cosine of some angle, I can say the square root of 1 minus sine squared of that angle. It's just instead of that angle being an x like it is over here, it looks like up here it's arcsine of x. Fine. I can rewrite this like this. And the advantage of having it written like this is I can now say that sine of arcsine of x is just equal to x. I can take advantage of this first fact and make this 1 minus x squared. If that's a little bit hard to see because of bad trig notation, let me rewrite that. Remember, when you have this little squared up here, what that means is sine of something is being squared. To cut down in parentheses, people write it right here. That's the standard. But really what that means is this right here. This right here is a lot better form to write it in, even though the parentheses are a little bit overkill, because it makes it easier to see that what you really have here inside these parentheses is the sine of the arcsine of x. And as I wrote right here, the sine of the arcsine of x is just equal to x. So everything inside this set of parentheses is just an x. This is equal to the square root of 1 minus x squared. Quite a bit simpler than what we had up there. And if cosine of arcsine of x is equal to this, then I can say that f prime of x, the thing that I was trying to figure out, is equal to 1 over this. Because up here it says f prime of x is 1 over cosine of arcsine of x. And that's it. You can do that same thing a couple more times, and that's not entirely true. We'll do that same thing one more time. Let's simplify the sine of the arccosine of x. I think that's what I was supposed to simplify second. Yeah, the sine of the arccosine of x. Well, I'm going to do the exact same thing. Except now I'm going to take advantage of the fact that the cosine of the arccosine of x is just equal to x. And using my sine squared plus cosine squared x, I should write that more carefully. Sine squared x plus cosine squared x equals 1 identity. Instead of solving for cosine, I can solve for sine. Let's say sine squared x is 1 minus cosine squared x. So therefore cosine of x, therefore sine of x is equal to the square root of 1 minus cosine squared x. So I'm trying to simplify the sine of this thing. Well, I know the sine of anything can be written in this form, so let's do it. The square root of 1 minus cosine squared of, and then instead of writing x like I have in this identity up here, I want to write arc cosine of x to make this thing equal to this thing. And as we saw over here, this is just the square root of 1 minus x squared. And so I can figure out g prime of x. G prime of x was negative 1 over this thing that I just simplified. So it's negative 1 over this thing right here that I just simplified. That's it. Last one, a little bit more challenging. In this last one, I want to figure out the cosine of the arctangent of x squared. So what I said down here is, okay, figure out the cosine of the arctangent of x and then plug that in up here, make it squared. Fine, I'll do that. Cosine of the arctangent of x. It's a little bit challenging. And the reason why is the things that I know, so let's see, maybe I'll write it here. Let's simplify the cosine of the arctangent of x. Well, if I do this same thing where I list everything that I know, the useful thing that I know now will be that the tangent of the arctangent of x is just equal to x. But I don't have tangent. I got cosine here. I'm going to have to change this into tangent somehow. So I'm going to have to write tangent in terms of cosine. Well, there's a few different ways you can do this. I think the easiest way we can do this is, again, start with our Pythagorean identity. But now I am going to divide both sides of this Pythagorean identity by cosine squared x. So I'm going to say sine squared x over cosine squared x plus cosine squared x over cosine squared x is equal to 1 over cosine squared x. Why did I do that? Well, first of all, why is that legit? If this is equal to this stuff divided by cosine squared has to be equal to this divided by cosine squared. Okay, I guess I see that's legit. Why'd you bother doing it? Well, sine over cosine is tangent. So sine squared over cosine squared is tangent squared. Cosine squared over cosine squared is just 1. And 1 over cosine squared, well, 1 over cosine is secant. So 1 over cosine squared would be secant squared x. I still don't see how this is useful. Okay, secant is related to cosine. All right, 1 over tangent squared x plus 1 has to be the same as 1 over secant squared x. But 1 over secant squared x is just cosine squared x. So therefore, cosine of x is equal to the square root of, how about this? Yeah, I'll write the whole thing. The square root of 1 over the tangent squared x plus 1. So I can take that fact and rewrite this. Instead of the cosine of x, I have the cosine of arctangent of x. So instead of it being equal to the square root of 1 over tangent squared x plus 1, it'll be equal to the square root of 1 over tangent squared arctangent x plus 1. What I'm saying is this is equal to the square root of 1 divided by tangent squared of arctangent of x plus 1. And I can simplify that because tangent of arctangent is just x. So this is the square root of 1 over x squared plus 1. So the cosine of the arctangent of x is this guy right here. That's not what I wanted, though. I want h prime of x. I want that thing squared. So h prime of x will be equal to this thing squared. Square and the square root cancel out. It's supposed to be a squared. Try to write it again. I get that h prime of x is equal to this guy right here. So let me throw some boxes around some answers, and then I will end this video here.